So my presentation will be on CRISPR-Cas9, and I will be discussing if we have gone too far. First, I will give an overview of the technology, show the main ethical questions, give two perspectives on these questions, and propose something that we can do now. First, the overview of the technology. CRISPR-Cas9. CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats, and Cas9 is an endonuclease that has been re-engineered to help cut DNA in a specific place. CRISPR-Cas9 is a gene editing system that was originally discovered in bacteria. The gene editing technique works like this. First, the Cas9 protein, which contains a guide RNA, will unzip and cut a double-stranded break at the position specified by the guide RNA. This double-stranded break can be repaired in two ways. So first, we have non-homologous end joining. This technique will allow the broken DNA strands to simply come back together through insertions and deletions. The second technique is homology-directed repair. This technique requires new DNA, so this donor DNA, to be incorporated into the sequence. Technique 1, non-homologous end joining, can be used to remove genes, while technique 2, homology-directed repair, can be used to insert new genes. The main ethical questions. So the first question is editing the germline wrong? A bioconservative would answer yes, while a bioliberal would answer no. Should we allow this technology at its current capabilities be applied without discussing the slippery slope of this technology? A bioconservative would answer no, while a bioliberal would answer yes. So what is a bioconservative and a bioliberal? So bioliberalism is the stance that biotechnology and the new values it entails should be embraced, while bioconservatism is the stance that urges regulation and relinquishment of biotechnologies that are potentially dangerous and immoral. Bioconservative arguments start with two main ideas. Conservation of common heritage is important, and enhancement is bad. From these ideas, we can say that future generations cannot consent to having edited genomes. Enhancement could give rise to eugenics once again, and that by doing these edits, we can alter human nature, and this will take us to a post-human moment in history. So bioconservatives would propose that all germline editing should be banned, as it is too dangerous and could have too many consequences, and that we have crossed an ethical and moral line. Bioliberals, however, would argue that there is no static human genome to conserve, and that enhancement can be helpful. From these two statements, we could say that every individual's genome is constantly evolving and mutating and is not something that can be conserved. The actual definition of eugenics is simply to select for desirable traits, which we have already been doing for centuries, not referring to the atrocities of the 1900s. Enhancement includes preventing genetic disorders and curing other patients with debilitating disease, so enhancement can be helpful in this way. Bioliberals would propose that genetic engineering should be adopted with caution. There could be unintended consequences through technical errors, but completely banning the technology is immoral. So what do we do now? I propose that we hold more conferences where scientists, ethicists, stakeholders, and more can come together to discuss these issues. However, in these discussions, there needs to be a clear scope of what will be discussed to get the ball rolling on the adoption of this technology. Germline editing is the most controversial aspect of this ethical debate, but it is not the application that could be implemented in a clinical setting. There needs to be more research done on germline editing to find ways to mitigate the technical risks like off-target modifications, and these studies can be done cautiously with a stringent regulatory framework. The most important piece to discuss is the application of this technology in somatic cells. Applying this technology to non-human organisms first in a commercial setting, we can gauge the safety of the technology by constantly monitoring adverse effects and seeing how the general public feels about it. Thank you. That's the conclusion of my presentation, and here's my bibliography.